You might recall from an earlier video that my master's degree is from Southern Cal, the true USC, not South Carolina. USC is the University of Southern California. And Mr. Pittman has encouraged us to wear our college shirts to school tomorrow. So that's what I'm going to do. And just to change things up a little bit, I thought I'd put on the old college visor that I wear for all the football games. I don't know if USC is on this week. I know there's some big games though. Michigan, Notre Dame is a big game. I can't think of any others off the top of my head. That's the one I'm going to be watching. I'll probably catch a Gator game. That's about it. Well, let's start chapter 4. Now chapter 4 is interesting because it's going to be a lot of new material for you. The first half of that chapter is just all about climate and weather and how it forms. All of this information is tested on the ACE exam and the AP exam. So I'll key you in on the important terms that you must remember as we go through. Some of these information that I give you is nice to know, but some of it is memorization. You've just got to know it. And I'll point those things out to you as we go along. So, chapter 4 begins on page 88. And this video will just cover basically the parts of the atmosphere. And then we'll get into what causes our weather to change so much. Here we go. I truly think it would be best if you follow along with your textbook, because I'm going to go over a lot of these diagrams with you. And this weather stuff, if you've never been exposed to it before, can get a little complicated. So put this thing on pause and go grab your textbook. First, a brief introduction to weather and climate. You're probably aware of this, but just to set the record straight, you know, weather is something that happens locally, that changes every day or 2 or 3, and it's not a long-term proposition. Climate, on the other hand, is a long-term proposition. We can actually keep track of organisms that live in a region based on climate. Alright, so this is chapter 4. It's about climates and biomes. It's really divided up into sections. The first section is a good explanation of how all these different weather phenomena occur. And I'll explain to you a little bit the difference between weather and climate. Once we get through all those phenomena and understand how they work, then the second portion of the chapter divides the Earth up into what are called biomes, which are regions of the world that have similar climates and so therefore have similar precipitation and organisms. Then the last part's about biomes of the water. Same idea. Salinity and temperature of water around the world tells us something about the organisms that might live there. So let's start first with weather. Weather, of course, is a local phenomenon. It happens every day or 2. We have a different weather pattern. And basically weather happens like this. Coming off the ocean, we have a warm front that blows in, and warm air rises, and it might rise either because of it encounters a barrier or just because it rises up. When warm air rises, then you get cold air that comes in underneath it. So these things are called cold fronts and warm fronts, and you hear the weatherman talk about them all the time. When a warm front collides with a cold front, that's when we get some weather activity in the form of rain perhaps, or even something a little bit more violent like a thunderstorm. These weather extremes are the things that we'll talk about in this chapter. And here's the first one, tornadoes. We're all familiar with them, I'm sure, and you can see from the diagram how tornadoes happen. ACE kids, you guys really need to be on top of exactly how this works, because they will ask very specific questions on the ACE exam. On the AP exam, things are a little bit more generalized. But here's how it works. You've got, again, a collision of warm fronts and cold fronts. And when that happens, we sometimes get this twisting action. And when we get this twisting action, two things happen. First of all, we get warm air rising on the outside in this clonic fashion. And then cold air will fall. And the cold air falls inside of this clonic action. And so then you've got warm and cold air colliding inside of the cone all the time. And because of that, it's very, very violent. And there's lots of energy inside of this funnel. You can see the funnel right here. Then we have hurricanes. We're all familiar with them. Hurricanes work similarly. They're a circular motion. You can tell from this diagram how the winds blow. But again, it's a cold front and a warm front sort of colliding, and then you get this circular motion. When you get this circular motion, a lot of times it forms cells, and that's what this diagram's showing you here, the different cells that form. With a hurricane, obviously tremendous energy is part of the deal, especially because hurricanes usually start over water. And when they start over water, they can pick up a lot of warm moisture from an ocean, and that just feeds into this warmer flow here in the center. Of course, you're all familiar with the eye of a hurricane. Now this front edge of the hurricane causes something called storm surge. And with storm surge, it's pushing water towards land. So as a hurricane heads towards the land, it's pushing ocean water with it. And it's that storm surge that causes so much flooding at the outset. The dangerous part of the hurricane is always this front part. Now the back part of the hurricane still has winds associated with it and some rain, but it's usually rain in the form of thunderstorms. The storm surge is really a push of the storm pushing ocean water, and so that's when that flooding begins to happen. When you combine the storm surge flooding with all the rain that happens on the back end, that's when things really get nasty. Of course, we categorize hurricanes as a category 1 through 5, with 5 being the most severe. Remind me to show you this video in class tomorrow. It's a good primer on all of the different types of wind and weather events. Cyclones, of course, are hurricanes that happen in the Pacific. You should be able to tell me the difference. This is a diagram you need to memorize. You need to know all of the layers of the atmosphere. Now, we already talked about the difference between weather and climate. Climate is long-term weather. It's weather over years and years of time. And we measure climate basically with two parameters, temperature and precipitation. Here are the layers. You need to learn them. The troposphere is the lowest layer, and it goes up about 10 miles or so. It's the air that we breathe. The troposphere is where most of our aircraft fly, and it's where most of our air pollution ends up. Very little of it ends up in the stratosphere, which is the second layer. But something you need to remember, at the top of each layer is a thin line that's called the pause. And the pause is named after the layer that it's on top of. So you start out at the bottom with the troposphere, and then you have a thin line that's called the tropopause. We go up to the stratosphere. The stratosphere, of course, is famous for one thing. It contains the ozone layer. The top of the stratosphere has a thin line that's called the stratopause. Then we have something called the mesosphere. Meso in front of anything means middle, so that's how I keep that one straight. So the mesosphere is the middle layer, and that's all you really need to remember about the mesosphere. And the thermosphere is next, and it's quite a ways up. The thermosphere is unusual because one would expect that as we got further and further away from the surface of the planet that things would get colder. But because the thermosphere contains just a rare amount of helium and hydrogen molecules, the sun's heat really gets in there. So we end up with temperatures, as you can see from this diagram, temperatures to get up like 1,000 degrees. So thermo means hot or heat. So you can remember the thermosphere is the sphere on top of the mesosphere, and it is very, very warm. And then the last layer is the exosphere, that's going up out into space.
In kilometers. The upper boundary of the troposphere is called the tropopause. The temperature of the troposphere varies from being warm, 17 degrees Celsius at the surface, to minus 60 degrees Celsius at the tropopause. Commercial jets travel at altitudes within the troposphere. Varying air pressures and temperatures lead to the movement of air masses. This movement drives the Earth's weather.
So the weather that we experience is all thanks to the troposphere as well.
The stratosphere extends from 15 kilometers to 50 kilometers above the surface of the Earth. The upper boundary of the stratosphere is called the stratopause. Stratosphere temperatures vary from minus 60 degrees Celsius at the lower boundary to 0 degrees Celsius at the stratopause. Cirrus clouds, which are composed of ice crystals, form in the stratosphere. The stratosphere contains a large band of ozone called the ozone layer. The ozone absorbs 99% of the harmful UV radiation from the sun. The mesosphere extends from 50 kilometers to 85 kilometers above the surface of the Earth. The upper boundary of the mesosphere is called the mesopause. The mesosphere does not have energy-absorbing ozone, and its temperatures reach as low as minus 85 degrees Celsius. X-type rocket planes travel at altitudes within the mesosphere. The thermosphere begins at the mesopause, 85 kilometers, and extends over 500 kilometers. The few molecules present in the thermosphere are constantly bombarded with radiation and can heat up to around 1,000 degrees Celsius.
Alright, so those are the layers with something famous about each one of them. Memorize these layers. You've got to know them and have an idea about the height that we're talking about here. You can see how much larger the thermosphere is than any of these other layers. Okay, well, I think that's a good place to stop because we get into a lot of other things and it takes a long time. So this took 15 minutes to what, do 2 pages? That's not good. I'm gonna have to speed things up a little. Anyway, see you next time.